In this video, we're going to go over how to get Python onto your personal computer, how to install packages, and how to use an IDE. Specifically, we'll focus on using Spider, which is built around the idea of scientific computing. So in order for us to get Python, we're going to use what's called the Anaconda distribution. So the Anaconda distribution of Python is built with the idea that you're not just using the base language, but you're going to want to use code and packages that people have written already. So we can go to anaconda.org, and here we'll go to the main web page for Anaconda. We can go to download Anaconda. So we click on that link, and it's going to take us here to Anaconda Distribution. And so you'll notice these, let's see, 3 by 5, these 15 boxes show us some of the libraries that come pre-installed in Anaconda, which don't come with the base version of Python. So we're getting some extra things by using this distribution, but they'll be pretty convenient to use. Now, Jupyter and Spider, those are environments you can code from. And then we have things like NumPy, SciPy, Numba, Pandas, Dask, etc. These are all scientific packages that people use for things like reading in CSVs or doing matrix math or even like plotting with like matplotlib. So all of that will come prepackaged with the Anaconda distribution. And so we're just going to want to download Python 3.7, or if you're watching this video a little bit later, this may have updated. But to do that, we're going to want to choose one of these two installers. Now, in order to see if your computer is a 32 or 64-bit system, we can come into our search bar here, and we can type in system and then control panel. Control panel. And right here, this is the recent. Let me actually back up for you. We can type in system, and in the settings bar, it'll have our system here. So control panel, system and security, system. And in here, it tells us our system type, a 64-bit operating system, or an x64-based processor. So that tells us we want to use this 64-bit graphical installer. I'm going to go ahead and close this out. Now I'll click on this, and it's going to download it for me. Now, in my case, where it downloads to, let me just go ahead and close that, is the downloads folder. Now you'll notice I already downloaded it yesterday. So this should work for us. Once it's downloaded, it'll take a little bit of time for you, maybe 2 or 3 minutes. What we can do is just go to the folder it was downloaded into. You'll notice in Chrome I can right click and say show in folder, and it'll bring it up. So we'll go to that folder, and we'll just double click on this to run the executable file. Okay, so I just shrink these windows down. So this is the installer for the Anaconda distribution. So what this is going to do is install Python 3.7 onto our computer, and with it, it's going to install all of these extra packages and libraries and stuff. This extra code people have written for us so that we can do things a lot simpler. Okay, so you can read through this if you want. You can also just click next. Here's a user agreement. Just click you agree if you agree with it. I'm going to install it just for me. So if you have multiple users on your computer, you can install it for all users, or as suggested, just do it for the single user you're on. Okay, now here, it's going to ask for a destination folder where I want to put mine. The default is users, student, or users, and then the username, and then Anaconda 3. But what's going to happen is if your username is something like John space Doe, that space in the user can actually cause some issues with the program later down in the line. So what I'm going to do is I'm going to hit browse, and I'm going to go to this PC. I'm going to go to my local disk C, and you'll notice I have a programs files x86, a user, and a Windows folder. I'm going to go ahead and add a new folder, and I'm going to call it apps. And then in this apps folder, I'm going to add a new folder. So I'm right clicking on the place I want to add the new folder into. And I'm going to call this Anaconda 3. So now this is the place I'm going to set as my installation location. So I'm going to install it into my apps Anaconda 3 folder that I just created. Okay, so it's telling me it's going to take 3 gigs of total space, and we have 150 gigs free, so we're good to go here. All right, so I'm just going to hit next. Now it's going to ask for some advanced options. We can add it to our path, which it doesn't recommend, or we can register on Anaconda as our default, which is probably okay. If you already have Python installed on your computer, especially like Python 3, this might be an issue, but you're almost certainly fine. You should know if this will be an issue or not. So just go with the default, and we're going to hit install. Okay, so it's going to start extracting all of the Python code, like all of the base Python distribution and all of the extra stuff that comes with Anaconda. All right, so while that's installing, we can just kind of briefly talk about what Python is and what we're going to be using it for. So Python is a programming language, and very often it's used for scripting. Now, Python is what's the word for it? Dynamic. It can be used in a lot of different ways. People use it for like object-oriented programming or functional programming. These are like 2 different paradigms of how to write software. And it's a very popular language. It's a good one to learn. Not only is Python free, it's distributed for free to anyone, anywhere, but it's also extremely popular. It's the second most popular programming language by like most metrics people use. Like the only one more popular than it is JavaScript, but that's primarily used for things like building websites and stuff. Whereas Python can be used for building websites, but it's also extremely popular for doing statistics, doing like data analysis, and doing scientific computing. And so we're going to lean a little heavier on that scientific computing aspect of Python. And specifically, we're going to be using things like SciPy and NumPy. These are libraries people have built that'll do a lot of like advanced math for us. Okay, so for the rest of the course, what we're going to be going over, I can go ahead and pull up a brief outline I've made. This is subject to change, of course. But for the rest of the course, what we're going to be going over are things like, well, this first video, which is getting Python, installing packages, and then using the IDE. We'll also talk about setting up a GitHub. What GitHub is it's like a website that uses what we call like version management, but which helps you keep track of code that you've changed and updated and allows people to work on code together. But it also is just very, very convenient for sharing code back and forth. So in this course, what we're going to do is we're going to set up a GitHub for every student, and then you will push your homeworks to the GitHub. And I'll tell you what that means when we start talking about GitHub. And then I can then pull all of your homework in an automated way and grade them all using some scripts I've set up. So after we sort of get like this week 1 kind of like get set up, get installed, get Python running stuff, we're going to then talk about just like the most basic things like regarding Python, like what a data type is, like what type of keywords you guys should understand Python's reserves, how to use math expressions, and how, just like the most fundamental aspects of Python operate. And then we'll get a little fancier with each additional week. We'll add in, using functions and conditions and classes in Python. And then we'll talk about working with iterables and learning how to work with arrays and like matrices and vectors in Python. And then we'll get more and more into math and doing like reading in data, doing differential equations, making beautiful plots with those results as we go throughout the course. So like the first half of the course is just getting comfortable with Python itself. And then the second half will be using Python for actual scientific uses. Okay, so these packages are still downloading. It should be fairly soon. Let's see. Does it give us any details here? It does not. Should be fairly soon. Once this is done, open up Spider, which comes as a part of the Anaconda distribution. We see Spider right here. So we can quickly go and type in Spider. Well, that didn't work. Here we go. Spider software. So Spider is an integrated development environment And this is where what we'll use to write our code. And since we're new to coding, it'll be really nice to have Spider because it allows us to visualize things we're doing inside of our code. So it'll tell us the structure of the code. It'll tell us what projects we have open. It'll help us interact with the code. It'll tell us if we're writing code incorrectly or not, and then it allows us to explore the code that we've run. So we'll stop the video here, and once the installation is done, we'll pick up how to get into Spider, and then we'll also pick up how to set up a GitHub and install Git onto your computer so you can very easily and quickly push code back and forth for the homework assignments.